Hello, hello. How is everybody this uncharacteristically, ridiculously nice fall afternoon in Michigan? No, it's always like this for our visitors. Welcome to Mcity's test facility here on the nether regions of the campus of the University of Michigan. I'm Greg McGuire. I'm the Managing Director at Mcity. I'm really glad you're all here. We got a lot of empty tables for our government friends. I hope they're on the golf course during this shutdown or wherever they are. But the good news is we're going to record all this. So thank you for the backs of your heads and your attention for the next couple of hours. A couple of housekeeping things. There are restrooms directly behind me. Please don't go through this curtain. You can go out and around. The test facility behind you will have moving vehicles under autonomy being controlled remotely during some of these demonstrations. It isn't a great idea to go wandering out there yourself. So please don't do that. Stay in here. If you need to go early, recognizing this is a beautiful Friday afternoon, Sue and Debbie in the back raising their hands can take you out to your car or however you came. I think that's everything. Would you like to see some interesting demos that we've prepared for the last a year plus? It's a lot of interesting work. All right. Let me then, without further ado, introduce our fearless leader, Mcity's director, Professor Henry Liu. Come on up, Henry. Henry will set the stage and give us some context, and then we'll get started. Thanks, Henry.
Good afternoon, everyone. Thank you for being here. I'm really glad to see you. We're doing this. This is second time we're doing this demo. Almost a year early, in October last year, we have similar demos. And so, first of all, let me thank National Science Foundation for their generous support. This is a project started exactly 3 years ago, and in 2022. And at the time, you can imagine we have Mcity physical facility for like 7 years. We've been operating this physical facility, and then we have researchers and also industry come to Mcity to do the test. However, most of the test, most of the work being done at Mcity is really restricted to University of Michigan and also the business within the Southeast Michigan. And so when we present this idea to National Science Foundation, can we open up Mcity to researchers nationwide so that everybody can use it? The way we're going to open up this facility is to build digital infrastructure. So you have seen the physical infrastructure we have, and that pretty much over the last 10 years, the physical infrastructure has been the same in terms of the scenarios and in terms of the facility and the equipment we have. However, in the last few years, really what we have done is to build the digital infrastructure on top of the physical infrastructure. And then so that this will give us the mixed reality of testing so that we can allow researchers nationwide to be able to access this test facility from anywhere, essentially anywhere in the world. And then from a researcher's perspective, this is also the figure we presented to the National Science Foundation. If you have an idea, this idea could come from a researcher, could come from a startup company. Then in the morning, you've seen we have lots of instrumentation in the city of Ann Arbor. So in terms of the test bed, we not only have this closed test track, we also have city of Ann Arbor as our living test bed. Right, so we collect data from the living test bed. Those are the real naturalistic environment, data from the naturalistic driving environment. And we use these data to build our simulation models. And so across this figure, you also see the cloud-based simulation as a service. And so that we build this digital twin to replicate the physical infrastructure at the same time. Although this is an empty physical facility, but we train the AI agent and to be virtual vehicles, virtual pedestrians, and to generate all sorts of scenarios in the digital world to mix it together with the physical world so that we have this mixed reality test environment. And then also, because we collect a large amount of data, we also want to make this data available too to the researchers. And so Mcity in the last couple of years also have been developing a data engine so that we can process these data. And then if you use these data to train your model, and if you see there's gaps between the performance of your model and also the data, then you can go back to these data set and it will help you to find interesting cases to help you to improve this model. So that's Mcity's data engine. And so with these, with this circle in terms of the data, the ability to process data, to identify interesting cases, and then to have the simulation model end to end. And so it's not only just the trajectories, but also sensor simulation, and putting it all together to create this mixed reality environment. And this environment connect to the cloud, which provided by our partner AWS. And on AWS, there's Mcity OS, Mcity operating systems, connect the digital world together with the physical world. Now, anywhere in the world, now you can access to our cloud, and through our cloud, you can access to our physical facility. Now, if you send out the command from Seattle, Washington, and then we receive from our cloud, and our cloud will forward that information to physical traffic signals and physical vehicles, and then those vehicles will be operated within the facility to test out your algorithm. At the same time, we get all the information from the physical facility, from our virtual simulation. Those information will send back to the remote control algorithms, and so that they can compute the next time step in terms of the control command. And so, so then with this, then you can produce and do your test and produce result, and now you can take that result to publish for whatever usage. And so that's sort of the idea of this Mcity 2.0. So really trying to open up the physical facility by building a digital infrastructure on top of it so that everybody else can access this facility. So this facility now not only a University of Michigan facility, it's become a facility of the transportation research community. And so that everybody can, if you have idea, if you have funding from NSF or others, and you can actually use this facility remotely. You don't have to come to Michigan to do the test. You can really do the test from at your desktop. And so that's sort of the idea. We, in the last 2 years also, the first year is our own development. The second year is a lot of these are our internal use case testing. The third year, last year, we've been really working with a set of partners, and which we will be doing some demonstration today, and to further develop the use cases. And then the last year, we will officially open up Mcity 2.0 for requests from nationwide, and so that people can use this facility and for their work. And so with that, I'm going to stop here in terms of the background, and then I'm going to ask my colleague Greg Stevens to come to the stage and to talk about some of the details of the work.
Hi, Greg Stevens. I'm the research director here at Mcity. And what I was going to take you through now is, we've talked about, Henry told you about Mcity 2 being a makerspace, basically. You have a good idea, you want to make it real, Mcity's the place. And so what I'm going to take you through is sort of like, what are the tools in this makerspace, right? And you'll see throughout all the demos that we go through today, all these tools getting used in certain use cases, and it allows people to think about what use cases they might have for the future that they want to do to progress their research or their industry project or other. So on the physical side, right, Mcity is very well known as a physical test track. That's where we're located right now. We have lots of infrastructure sensing, lots of cameras and connectivity features up on poles. We have a lot of remote control features, like we can remotely control all the states of all the traffic lights, or we can put the railroad crossing up and down, things like that. Thanks to our partner Humanetics, we have strikeable robotic test dummies, so adult and child dummies on robotic platforms that we can run in front of autonomous vehicles to see how well they handle that. As if, Michigan didn't have adverse weather at times, we can generate adverse weather. Thanks to our partner Techno Alpine, they have given us a snowmaking machine. So in the winter, we can make snow if it's not already snowing. And in the summer, we can make rain. This is especially important as AV companies start thinking about moving more and more northern, right? Right now, they're sort of southern in the good weather states, but eventually, if they want to take on New York, Boston, Chicago, Detroit, right, they got to deal with adverse weather. We also have autonomous test vehicles that are available for use. We also have drones. There's onboard sensing and compute and by-wire actuation available for all those. And thanks to Verizon and AWS, we have the high-speed cloud connection that allows us to get data and commands on and off the vehicle. Then, the NSF funding has really allowed us to extend into the digital world, right? And the first tick there is the digital twin, which you see in the video there. We actually have 3 digital twins that we've made openly available. One is in Carla. This one that you're seeing right now is in NVIDIA Omniverse. NVIDIA did an awful lot of great work to help us make sure all the material properties are proper inside this world, so that third tick there, high fidelity sensor models, when those models send out energy in the virtual world, all these surfaces and all the pieces, all the assets within the environment reflect back that energy like real sensor data, sensor energy would be returned, say like when a radar sends out radio waves and then receives them back. We're doing the same thing in the virtual world with NVIDIA's high fidelity sensor models. We also have a driving simulator, which our partner VI Grade donated for Mcity use. But you'll also see today one of our use cases is integrating the University of Buffalo driving simulators in. And that allows us to do mixed reality, which Henry described, right? Which is you can have a real vehicle on the real road with real sensors showing real, humanetics targets in the world. And then you can have in the digital world, the vehicle basically driving the same place in synthetic world, seeing the same things, and we can insert virtual objects in the synthetic world that the physical vehicle driving around the track will see. So that's the idea of mixed reality. And adversity orchestration is the idea that we need to populate this world that you see with vehicles, with pedestrians, with scooters, and we need to have them behave in an adversarial fashion to test the AV simulation stack that we have on the vehicle. And so that's what TerraSim, which also has been released open source, does. And then the last part is the data engine that Henry mentioned, where basically we have our own dedicated cluster for training and inferencing. And what you can do is you can take your AI model, figure out where it doesn't work, come to Mcity, take new real data or synthetic data, use that to retrain your model, and then retest. And I think I forgot to mention one of the 3 digital twins because we have a third digital twin, which is a Gaussian splat digital twin from our partner Parallel Domain. So if you know about Gaussian splatting, it's very photorealistic. So actually, a lot of times when people see the Gaussian splat digital twin, they don't even realize that it's not just a movie. So that's sort of the idea of the tool set that we deliver to folks that they can use in the makerspace to investigate any of the use cases that they want to develop. And now, sort of as the thought starter, we're going to show you 4 demos of 4 different use cases, how 4 different research teams and industry teams have used the Mcity makerspace to create useful work for their companies or their research organization.